The technical specification of passive optical multiplexers always include things like the insertion loss, link loss, return loss, and also the isolation. But what do all these individual parameters actually mean, and why are they so important to consider when designing a WDM setup? If you want to find out, stick around and we'll check it out. So let's start off with the most commonly known one, in other words, the insertion loss. And basically the insertion loss describes the amount of optical power that is lost while the signal passes through an optical multiplexer. Now the important thing to note about the insertion loss is actually that when the multiplexers are based on a thin film filter technology, in other words a filter cascade, the insertion loss actually will be different for each individual port. The reason for this is the filter cascade in itself. Because if you look here at this drawing, you will see that the signal being inserted into the filter that is at the end of the filter cascade will also be reflected from all the other filters, and each reflect will introduce another small optical power loss. So in other words, depending on where within that filter cascade the signal is being introduced, the insertion loss will be higher or lower. And that's why in the data sheets the specified value for the insertion loss is always the worst case scenario. When we're talking about a WDM setup, we're normally talking about a link. In other words, we've got a multiplexer and a demultiplexer. And this is where the link loss comes into play, because the link loss actually describes the accumulated loss through the multiplexer and the demultiplexer. And that makes the link loss value ideal if you're calculating the optical budget of a WDM link. Now there is one important thing to know about the link loss, and that is that it is based on an ideal pair of multiplexer and demultiplexer, especially when we're talking about, once again, the filter cascade. As I described beforehand, with a filter cascade, the insertion loss for each individual channel can vary because depending on the position in the filter cascade. And that's why what we do is actually we invert the filter cascade of the demultiplexer to the filter cascade of the multiplexer. In other words, the channel that on the multiplexing side has the highest insertion loss will have the lowest insertion loss on the demultiplexing side. And by doing this, actually the link loss for each individual channel will always be the same. So now let's talk about return loss. And basically what that is, that when an optical signal passes through a fiber cable, some of that signal is always reflected back. And the reasons for this can be a fiber splice or maybe even a filter. But the main reason for optical return loss are always the fiber connections. Now when we're talking about lower data rates, the biggest negative effect of return loss is the actual loss of optical power because some of the light is being reflected. However, when we're talking about a data rate of 100 gig or higher, then another negative effect actually becomes stronger, and that is the negative interference of the reflected light with the original signal. Now, the optical return loss specified for a multiplexer describes how much return loss the multiplexer itself actually introduces. And since the return loss is a negative value, of course you're looking for a higher number to have a better return loss. The last thing we need to talk about is the isolation. And basically what the isolation describes is how well the individual channels of a WDM are actually separated from each other. Now it is always the case that the light from one channel will always bleed into the adjacent channels because there is no such thing as the ideal filter that will prevent that. But the question is, how much? And that's what the isolation describes. The isolation actually describes the ratio of the light intensity of the desired and undesired port. So, I hope you learned something today and that you enjoyed this video. If so, please leave a comment. Also, please let us know if you have any further questions regarding this topic and leave them in the comment. So, until then, see you in one of the next videos. Bye bye.